All right, let's begin with the class. Inshallah, we are going to understand integration general category today. And before we, just like differentiation, I have divided integration into three categories: the general category, and then integration by parts, and then integration by substitution. The first category is integration general category. Uh, and when we are starting with general category, we'll be reviewing a bit of AS integration part as well. So what we actually studied in AS integration in P1, in pure maths 1, we know that integration is the reverse process of differentiation, right? Differentiation takes us forward. We are differentiating, it takes us forward, and integration brings us backwards again. Differentiation हमें आगे लेके जाता है और integration वापस हमें पीछे ले आता है. So integration is the reverse process of differentiation. Differentiation takes us forward and integration brings us backwards. This means in integration, we have to do something which is opposite to that of differentiation. So what we do in differentiation, and if we talk about normal algebraic functions, what we do in differentiation, we multiply the power and then we subtract the power by 1. If it's nx power, if it's x power n, then we multiply the power and the power gets subtracted by 1. This is differentiation. So in integration, we add 1 to the power and then divide the new power. First, we increase the power by 1. We increase the power by 1. And the new power that we have obtained, we are going to divide that. So multiply the, first we do multiplication, then we do subtraction. Over here, first we do addition, and then we do division. So integration is the reverse process of differentiation, as we can see over here as well. Now, there are two types of integrals that we have studied. Whenever we have to divide, whenever we have to integrate an expression, and the limits are not defined, limits, integrate from 1 till 3, lower limit, upper limit. If the limits are not defined, then such integral is known as indefinite integral, and indefinite integral will result in an expression. An expression will be given, and when we are going to integrate that, we are going to get another expression. And when we are going to get another expression, we will also be writing plus c to that. In AS, we have studied why we do plus c. What is the reason behind taking plus c? We are not going to go into that depth as of now, but we know that whenever we are integrating, we have to take plus c if we are dealing with an indefinite integral, that is without limits. So the limits are not defined and the integral is indefinite, then a constant of integration must be added. However, if the integral is a definite integral and there are defined limits, then in that case, we will not get an expression. We will not get an expression. Rather, we will get a value. In indefinite integral, we get an expression. But in definite integral, we get a value. So whenever we have to find the area, whenever we have to find the volume, in AS also we only used to find those. We always used to get a particular value, a particular number at the end. Why? Because we used to apply the limits, upper limit first, then lower limit, then we used to subtract, and then the answer that we used to get was a number, non-exact or exact whatsoever, but that was a number, right? So this means that whenever the limits are involved, we do not get an expression, rather we get a number. And also we need to remember that whenever we are dealing with a definite integral, no need to add constant of integration. Sir, why? Whenever we are integrating, we need to have a constant. Yes, but in case of definite integral, we do not find the constant of integration. Why? Because when we are going to substitute the limits, upper limit and lower limit, and we are going to subtract, then even if we have found the value of constant plus c, even if we have been able to find the value of that constant plus c, then also it is of no use. Why? Because the constants will get cancelled out. Upper limit minus lower limit plus c minus c will get cancelled out. So when something is to be cancelled after application of limits, what is the use of finding that? Why are we spending time on finding that? Why are we wasting our precious time? So whenever there are limits, we get a value, we do not get an expression. And in such cases, do not add a constant of integration as it gets cancelled when limits are applied. So this is what we studied in AS. Then two rules that two rules of integration that we followed in P1 were integration of x power n is x power n plus 1 upon n plus 1 plus. What we have done? We have added 1 to the power and the new power is being divided. This is what is written over here. Normal algebraic expression, add 1 to the power and the new power is being divided, and because there are no limits, we have to take plus. Then we dealt with composite functions in which there is a function and at the top of the bracket there's a power. There's a power on the entire function. There's a function inside the bracket, and at the top of that bracket there's a power which is being applied on the entire function. So what we do is we add the power by 1 and we divide the new power. We add the power by 1 and we divide the new power, and apart from that, whatever function is there in the bracket, the differentiation of that is also divided. But even in AS, we studied that the function inside the bracket will always be a linear function. The function inside the bracket will always be a linear function. That is why I have not written fx. I have not written fx. I have written ax plus b. Just to let you all know that the function will be linear function. The function will be a linear function. So that is why whenever there's a non-linear function, definitely the differentiation of a non-linear function will again be a function, and in that case we will have to divide by the variable. So in integration we do not divide by the variable. So that is why whenever the function is being given to us, the function inside the bracket will be a linear function, and the differentiation of a linear function is a constant, and it is basically the coefficient of x only. So this means that whenever we are integrating a linear function, we are going to add 1 to the power, and the new power is being divided, and the coefficient of x, which is basically the differentiation of the linear function, will be divided. Because differentiation of composite functions, in differentiation of composite functions, we use to multiply the differentiation of the function. But over here, we divide the differentiation of the function. But as that function is always a linear function, so the differentiation of that will always be the coefficient of x. If it's 2x plus 1, the differentiation is 2. If it's minus 5x plus 1, the differentiation is minus 5. So we always divide by the differentiation, and that is always the coefficient of x. So over here, ax plus b whole power n increased by 1, became n plus 1. The new power got divided, and the differentiation of the function within the bracket is a, so that is also divided. And because the limits are not there, so we have taken constant of integration plus. Then if you are going to apply the rules on these 3 examples, then how can we do that? Just check it out. The normal algebraic function being integrated, 3x cube, 3x power 4 upon 4, plus 5x cube upon 3, plus 8 became 8x, and plus c, because it's indefinite integral. And if we talk about a composite function, this rule, then 2x plus 3 whole power 5, power went up by 1, power 6, new power got divided. The differentiation of the bracket, that is 2x plus 3, is divided, and that is 2. And at the end, we are taking plus c because it is indefinite integral. The limits are not defined. So this is 1 upon 12 times 2x plus 3 power 6 plus c. Now this third example seems to be a normal algebraic function, just like example number 1. So we can integrate directly as well. How? Increase the power by 1 and divide the new power. So 2x power 1 becomes 2x squared upon 2, and 3 becomes 3x. But over here, we have not taken plus c. Why? Because we know that they are defined limits. So we will not take plus c. Rather, we are going to apply the limits. So upper limit minus lower limit. So this 2x squared upon 2 plus 3x becomes x squared plus 3x. Applying the upper limit, 5 squared plus 3 times 5 minus 1 squared plus 3 times 1. And we subtract and we get 36. So even if we take plus c over here, then plus c over here and plus c over here will have got cancelled because of this minus. And that is why we have not invested our time in finding out the constant of integration plus c. So during definite integrals, there is no need of finding plus c. Over here, I've taught another way of doing it as well. Now, this is the normal thing that you would have got in your mind. Normally, students are solving like this as well. But at times they see alternative solutions in marking scheme, and then they get confused as to why the alternative solution is there when there's only one possible way. So I always tell them that no, the another perspective of dealing with 2x plus 3 is 2x plus 3 whole power 1, because 2x plus 3 is a linear function. So we can assume that there's a bracket around 2x plus 3 and there's a power of 1. So if we deal it like a composite function, then the power 1 goes up by 1. It's 2x plus 3 whole square. The new power gets divided. The differentiation of the bracket also gets divided. The 2x plus 3 whole square divided by 2 times 2. And then we apply the upper limit and lower limit and we subtract, and even then we are going to get the answer 36. So both are the possibilities. Any possibility can be followed, right? So multiple methods in marking scheme usually confuses students. So I have explained why that the second method is also applicable. So we can treat this 2x plus 3. This is not always the case. Over here, we cannot treat this 3x cubed plus 5x plus 8 as a composite function. We cannot do that, right? Because this is not a linear function, rather it's the cubic function. So as the function was a linear function, then only we can follow this strategy that the entire function within the bracket and the whole bracket has a power of 1. So this is only possible over here. I think I've explained all 3 examples. मुझे लगता है मैंने तीनों examples सही से समझा दिए. If you think anything is required over here, anything that you need to understand, just let me know. And if you have noted these 3 examples down, if you made the notes of this, just write done and clear in the chat so that I can move forward. Yes, Xavier.
So the 2 parts before example, part 1 and part 2. The difference between them is just the whole bracket, right? मतलब second वाले पे whole bracket है और first वाले पे नहीं है.
बिल्कुल. फर्स्ट वाले में अलग अलग टर्म्स हैं और हर हर टर्म के ऊपर एक पावर है, जैसे यहाँ नजर आ रहा है आपको. और सेकंड वाले में पूरा फंक्शन ब्रैकेट के अंदर है और होल ब्रैकेट के ऊपर एक बड़ी पावर है. देखिए होल ब्रैकेट के ऊपर पावर अगर 2 होगी वो तो खोल के ऐसा बन जाएगा एग्जाम्पल 1 जैसा. बट इफ द पावर इज लाइक 3 और इफ इट्स 4 और 5 तो उसको खोलना मुश्किल होता है ना, फिर खोलने में बहुत टाइम लग जाएगा. अगर वो बाइनोमियल से खोल लिया जाए, बाइनोमियल जो हमने ये इसमें भी पढ़ा हुआ है, उसको अगर बाइनोमियल से खोल लिया जाए तो वो बन जाएगा नॉर्मल, बट फिर उसको खोलना पड़ेगा. बट इफ अगर उसको बगैर खोले हमें करना है विदाउट एक्सपेंडिंग दैट, तो फिर ये सेकंड रूल फॉलो होगा.
अच्छा, तो if it's square तो हम मतलब दोनों भी मेथड यूज कर सकते हैं, राइट?
बिल्कुल. स्क्वायर होगा तो फिर तो बहुत आसानी से खोल लेंगे. ए प्लस बी होल स्क्वायर इज ए स्क्वायर प्लस 2ab प्लस बी स्क्वायर. फिर वो एग्जाम्पल 1 की तरह बन जाएगा. उसके बाद हम नॉर्मल रूल नंबर 1 के थ्रू इंटीग्रेट कर सकते हैं उसको.
सही है सर, ठीक.
Right? Please copy this down and let me know if it's copied so I can move forward then. Moving forward towards the A2 part then. Yes, Xavier.
So sir, for the second one, for the second method to be applicable, उसकी कंडीशन यही है कि सारों के पावर्स एक जैसा होना चाहिए.
सारों के पावर्स मतलब
मतलब जितने भी वेरिएबल्स है ब्रैकेट के अंदर, या
ये सेकंड
वो.
एग्जाम्पल की बात कर रहे हो?
जी जी.
नहीं नहीं, सबकी पावर्स एक जैसी, मतलब ए एक्स प्लस बी है ना. तो एक एक एक्स पावर 1 वाला है कोएफिशिएंट है और एक विदाउट एक्स वाला लीनियर फंक्शन होना चाहिए. इन द ब्रैकेट विद इन द ब्रैकेट देयर हैज टू बी अ लीनियर फंक्शन, मतलब ऑफ द फॉर्म ए एक्स प्लस बी.
अच्छा, ठीक है सर.
सही है. जैसे 2x प्लस 3 पावर 5 है तो 2x प्लस 3 है, लीनियर फंक्शन है विद इन द ब्रैकेट्स. Once you have written it, please write clear and done. All right, if we move forward towards the A2 part, then now we have to see integration of exponential, logarithmic, and trigonometric functions. So let's look at the integration of exponential. If it's e power ax plus b, so if we recall the differentiation of e power fx, you were told that the differentiation is e power fx as it is copied, and then the differentiation of the power will be multiplied, right? E power fx is e power fx into f prime x. So over there, I wrote fx in the power. But over here, I have not written fx. I have just written ax plus b. Why? Because in integration, during integration, the power will not be any random function. Rather, it has to be a linear function. Just like when dealing with composite functions in differentiation, the function within the bracket could be linear or non-linear. But during integration, the function within the bracket has to be a linear function. Similarly, over here, the power of e has to be a linear function. So the integration rule is e power fx as it is copied, and the differentiation of the power will be divided. Yes, you have heard it correctly. Differentiation of the power will be divided. We are integrating it, but the differentiation of the power will be divided. But I've not written it like this. Why have I not written it like this? E power fx upon f prime x. Because this could have guided you wrongly that there could be any type of function in the power while integration. But that is not the case. During integration, the function is always a linear function. The power is always a linear function. So it's e power ax plus b as it is copied, e power ax plus b, and the differentiation of the power, that is definitely a, will be divided. So the power has to be a linear function. So e power ax plus b upon a plus. Then we remember that the differentiation of ln x was 1 upon x. The differentiation of ln x was 1 upon x. So the integration of 1 upon x will be ln x. Integration of 1 upon x will be ln x. Then if let's suppose if it was ln ax plus b and we used to integrate it, what we used to do? Sorry, we used to differentiate it. So ln ax plus b was, let's suppose if I'm going to change it and if I'm going to write ln ax plus b when differentiated, that's 1 upon a upon ax plus b. Remember, 1 upon ax plus b one upon ax, wait, one upon ax plus b multiplied by. So we used to know that whenever there was a function with ln, after differentiating, the function used to come in the denominator and the differentiation was being multiplied. Or I used to say that the differentiation used to come in the numerator. So the same can be applied here as well. If you are going to integrate 1 upon ax plus b, then it is going to be ln ax plus b divided by a. Integrating a upon ax plus b will give us ln ax plus b. But if you are integrating only 1 upon ax plus b, then it is going to be ln ax plus b divided by a. So this is what is written over here. 1 upon ax plus b, when integrated, will give us ln ax plus b upon a plus. Then if we look at the integration of sine, cos, and sec square, then we used to remember that the differentiation of sine x was cos x, and the differentiation of cos x was negative sine x. So now as we are integrating, so the integration of cos x will be positive sine x, but integration of minus sine x will be cos x. Integration of minus sine x will be cos x. So the integration of only sine x will be minus cos x. Because cos x differentiated gives us minus sine x. So minus sine x integrated will give us cos x. So if we are only going to integrate sine x, we are not going to integrate minus sine x, only integrating sine x. This minus will be multiplied over there. So the integration of sine x will be negative cos x. So this is what I've written. How do we remember it, right? This is given the formula sheet as well. The first thing, sine x differentiated gives us cos x. Cos x differentiated gives us negative sine x. And tan x differentiated gives us x square x. So if you are going to integrate, over here it's written differentiation, fx and f prime x. So if we look at integration, then cos x will become sin x will become minus cos x, sec square will become tan x. Look, fx and integration of fx. Sin x becomes negative cos x becomes positive sin x, sec square becomes tan x. 1 upon x becomes ln x. It is the usual practice of the examiner that x is taken within the modulus sign. Why? Because even if the x is negative, then on the basis of this modulus, the negative number will become positive and then ln could be applied on that. So that is why whenever the examiner is involving ln, he is writing the function within the modulus sign, absolute value of that. So e power ax plus b is e power ax plus b upon a plus c. 1 upon ax plus b is ln ax plus b upon a plus c. Sine of an angle is integrated and becomes negative cos angle divided by the differentiation of the angle. But again, the angle will always be a linear function. In differentiation, there is no such restriction of being linear. Exponential could have a power of, the power of the exponential function could be non-linear function. The angle on which sine, cos, tan is being applied is also a linear function. Yes, the modulus part is that I have written ln ax plus b upon a plus c, right? I should have written, although I can write like this as well, but it's at times the examiner uses the modulus in place of brackets. Ln ax plus b upon a plus c, the examiner uses modulus. Why does he use modulus at times? Although even if we do not use modulus, we will not be penalized on that. But writing modulus actually means that even if the value of the variable is such that that within the modulus we get a negative number, so because of that application of modulus, the number will become positive and then ln will be applied on that, because ln cannot be applied on a negative number. ये बात हम जानते हैं ना कि ln negative number पे apply नहीं होता, lg या ln कभी negative number पे apply नहीं होता. लिहाजा मॉडल्स लगाने का मकसद ये है कि अगर वेरिएबल की कोई ऐसी भी वैल्यू है कि फंक्शन का आंसर नेगेटिव आ रहा है, तो ln या lg उस पर लगे, ln जब उस पर लगेगा तो वो अनडिफाइंड हो जाएगा ना. इसलिए मॉडल्स लगाने का मतलब है कि अगर अंदर नेगेटिव भी आएगा तो बाहर आके पॉजिटिव हो जाए, ताकि उस पर ln लग जाए और वो अनडिफाइंड ना हो, बस ये बताए. लेकिन आप अगर प्रैक्टिस के तौर पे ब्रैकेट भी यूज करते हैं तो कोई मसला नहीं है, नथिंग, नॉट अ बिग डील एट ऑल. I was saying that sine of an angle when integrated will give us negative cos angle, and then the differentiation of the function within the bracket will be divided, but the angle will always be a linear function. In differentiation, the differentiation of the angle was being multiplied. Over here, the differentiation of the angle is being divided. Over there in differentiation, the angle could be a linear or a non-linear function. But over here, the angle will always be a linear function. In integration, the angle will always be a linear function. So sine angle becomes negative cos angle divided by the differentiation of angle. Cos angles become sine angle divided by the differentiation of angle, which is a linear function. So it's always a plus c. Sec square angle becomes tan angle divided by a plus differentiation of the angle divided plus c. And the angle is always a linear function. अच्छा अब देखें, tan becomes sec square, tan differentiated to sec square integrated to tan. यहाँ कोई मसला नहीं. Sine when differentiated gives us positive cos, साइन व्हेन इंटीग्रेटेड गिव्स अस नेगेटिव कॉस. याद रखने के लिए ये सोच सकते हैं कि साइन डिफरेंशिएट होकर पॉजिटिव कॉस बनता था, तो साइन इंटीग्रेट होकर नेगेटिव कॉस बन जाएगा. हालांकि याद रखने की जरूरत इसलिए भी नहीं है कि फॉर्मुला शीट ने ऑलरेडी बताया है कि क्या पॉजिटिव क्या नेगेटिव, तो फॉर्मुला शीट से आप हेल्प ले सकते हैं, कोई मसला नहीं इतना बड़ा. सही. तो साइन एंगल इज नेगेटिव कॉस एंगल. बस याद ये रखना है कि जो भी एंगल होगा अगर वो लीनियर फंक्शन है तो उसकी डिफरेंशिएशन डिवाइड होगी. द डिफरेंशिएशन ऑफ द एंगल विल ऑलवेज बी डिवाइडेड. तो साइन गेट्स कन्वर्टेड टू नेगेटिव कॉस, ये फॉर्मुला शीट में बताया हुआ है. इट इज रिटन इन द फॉर्मुला शीट. Sine angle is negative cos angle divided by the differentiation of angle. Cos angle is sine angle upon differentiation of angle. Sec square angle is tan angle upon differentiation of angle plus c. Because it's indefinite integral, so we are adding the constant of integration plus c. Are we clear with these 5 rules that I've explained? Give acknowledgement till here so that I can move forward. Okay, now these 2 rules that are written, that integration of tan ax plus b is negative ln cos ax plus b upon a plus c, and cot ax plus b is ln sin ax plus b upon a plus c. Although these can be memorized, but the examiner does not expect us to rectify this. Rather, it is this has been derived using integration by recognition, which I am going to explain in a while, inshallah. Right? So the integration of tan, the integration of tan angle and cot angle is not written over here, right? But it will be derived using integration by recognition. So this is commonly tested. At times the question comes on this, but I have written this as a rule over here, but I've also written that these are to be covered using integration by recognition. So we are going to look back at it once we have understood integration by recognition. What is integration by recognition? We are going to look at it right now. Okay. As just ignore them for now, and we are going to come back to it later, inshallah, in a while, inshallah. Okay, so these are the examples that are going to be that are basically will serve as an application of those five examples, five uh, types of integration that I've covered. The examples are as follows: exponential, e power 2x plus 3, integrated, e power 2x plus 3 divided by 2 plus c. Then 1 upon 2x plus 3 whole square, we know that whenever there's a function in the denominator and we have to integrate it, we bring it to the numerator. Whenever the function is in the denominator and we bring it to the numerator, whenever the function is in the denominator and we have to integrate it, we bring it to the numerator. This is what we know, right? ये बात हमें पता है कि जब भी function denominator में होता है तो हम उसको numerator में लेके आते हैं, फिर integrate करते हैं. So if it is 2x plus 3 whole squared, what we are going to do? We are going to take 2x plus 3 whole square to the numerator. It will become 2x plus 3 power minus 2. Then what we are going to do is, we are going to add 1 to the power. So 2x plus 3 whole power minus 2 plus 1. Then the power will be, the new power will be divided, which is minus 1. And the differentiation of the function within the bracket will also be divided. So if there's a function in the denominator, we took it to the numerator, it became a composite function. 2x plus 3 whole power minus 2, and the rule of integration of composite function that we studied in AS only will be followed. The power is added by 1, the new power gets divided, and the differentiation of the function within the bracket will also be divided. So likewise, we have got the final answer. Now the question is, sir, if there is 2x plus 3 in the denominator, shouldn't we do the same as we have done in example number 2? So now there's something interesting that I have to tell you. If you check out this rule 1 upon ax plus b, I have not guided you to take it to the numerator and then add 1 to the power and then divide the new power. Why? Because I know that this particular thing gets converted to ln. But how will we remember this in the exam? Let's suppose if we are given 1 upon 2x plus 3. Exam में अगर 1 upon 2x plus 3 आ गया मेरे सामने, how will I know what I have to do? What I can do, I could have thought that this is a bracket within them, and I could have taken to the numerator. So the question is that even if I think like that, and if I bring this to the numerator and I write it as 2x plus 3 whole power minus 1, and what I will do, I will add 1 to the power. As soon as I add 1 to the power, I will realize that the power has become 0, and the new power will be divided, and 0 will be divided. So in maths, 0, 0, dividing by 0 is a big no. We cannot divide by 0. So even if the exam, this comes to your mind that you have to bring the function to the numerator and then you have to apply the rule of composite function. And if you're applying and you see that the power gets 0 and you have to divide by 0, then there is an alarm that must ring in your mind and brains. There is something wrong. There is something wrong. There is something wrong. What that something wrong is? That something wrong is that it will be converted to ln and it should not be treated like a composite function. ये घंटी दिमाग में बजनी चाहिए कि ये कॉम्पोजिट फंक्शन की तरह ट्रीट नहीं होगा, ये कॉम्पोजिट फंक्शन की तरह ट्रीट नहीं होगा. This will be converted to ln. So even if by mistake at times you bring the function, if you take the function to the denominator if you shift the function from denominator to the numerator and you realize that after the adding the power by 1 it is becoming 0, so then you have to revert back and you have to see that there's something wrong, and then you have to realize that this is ln case and this will be converted to ln. So this is what I've done over here. 1 upon 2x plus 3 as per rule number 2. 1 upon ax plus b becomes ln ax plus b upon a plus c. So this becomes 1 upon 2x plus 3 becomes ln 2x plus 3. And the function is a linear function, so the differentiation of that will be divided. So ln 2x plus 3 divided by 2 plus c. Now the fourth example, I've made it bold, right? You can see that it's bold. So why have I made it bold? Just to let you all know that whenever there's a function of the form 1 upon ax plus b, but there is something that we can take as common, that it is essential for us, then it is essential for us that we take it as common. If you will not take it as common, then we'll get a wrong answer. How? Just check it out. Let's suppose if it's 1 upon 4x plus 8. What are we going to do? Firstly, we are going to take 4 as common. And if we take 4 as common, then it will become 1 over 4. Then 1 upon 4, it will become 1 upon x plus 2. And then 1 upon x plus 2 is ln x plus 2 upon 1 plus c. So writing 1 is not essential because the coefficient of x is 1. The differentiation of x plus 2 is 1. So we have not written 1 in the denominator. So the bottom line is that whenever there's something that is common, you have to take it as common, and if you have to take it out, otherwise your answer will not be correct. So 1 upon 4 times 1 upon x plus 2 becomes 1 upon 4 ln x plus 2. Let's suppose if you forget to do this, what you will do? You will have written like this: ln 4x plus 8 divided by 4 plus. Now just check out that 1 upon 4 times ln x plus 2 is not the same as 1 upon 4 times ln 4x plus 8. And even if you are going to now take 4 as common, nothing could be done, because even if ln is going to be applied on that, the answers will be different. So that is why what we have to do is we have to take that particular number as common before we integrate it. So integration of 1 upon 4x plus 8 is 1 upon 4 taken as common. The 4 is taken as common in the denominator. Then 1 upon x plus 2 will be integrated, and we will get 1 upon 4 times ln x plus 2 plus. So to get a simplified answer, to get a correct expression, it is essential for us to take common. Then we know that sine angle is negative cos angle. The differentiation of the angle is divided plus c. Cos 2x plus 3 is sine 2x plus 3 upon 2 plus c. Sec square 3x minus 2 is tan 3x minus 2 upon 3 plus. So this is what I've covered. All the examples have been covered. Just write all the examples and let me know that whether you are clear with all the rules still here. Yes, Javier, when the denominator comes to 0. I'm saying that whenever in example number 3, if you mistakenly take it to the numerator, firstly you should identify it at first instance only. पहले ही आपको फौरन पिक हो जाना चाहिए कि अगर डिनोमिनेटर में एक लीनियर फंक्शन है और होल ब्रैकेट के ऊपर कुछ पावर नहीं है, वो 1 है, तो वो ln वाला केस। बट लेट सपोज अगर गलती से आप ये नहीं पिक कर पाती और आप डिनोमिनेटर वाले फंक्शन को न्यूमरेटर में लेकर जाती हैं और आपकी जो पावर 1 है वो पावर -1 बन जाती है, और फिर उसको कॉम्पोजिट फंक्शन की तरह ट्रीट करने के लिए आप पावर में 1 ऐड करती हैं, तो आपको फौरन पता चल जाएगा कि पावर क्या हो रही है, 0। और जैसी पावर 0 हो रही है तो फौरन घंटी बजनी चाहिए कि यार पावर 0 कैसे हो सकती है। पावर अगर 0 हो रही है तो मुझे 0 से डिवाइड करना पड़ेगा, और 0 से डिवाइड करना तो एक मसला है, ये तो हो नहीं सकता। तो वहां घंटी बजनी चाहिए कि अरे ये क्या हो रहा है, ये क्या कर रही हूँ मैं, तो गलत कर रही हूँ। तो उस केस के अंदर फिर आपको फौरन घंटी बजनी चाहिए कि ये लीनियर फंक्शन है डिनोमिनेटर में, लिहाजा ये एन वाला केस है, तो लिहाजा मैं इसको इस तरह से डील कर रही हूँ, तो ये गलत कर रही हूँ, लिहाजा वापस आप अपनी वर्किंग को काट के और सही काम कर लेंगे। वैसे तो डायरेक्ट पिक होना चाहिए कि अगर डिनोमिनेटर लीनियर फंक्शन है और वो भी होल ब्रैकेट की पावर 1 है, तो वो एन वाला केस ही डायरेक्ट पिक होना चाहिए। बट गलती से भी गलती हो रही हो तो फिर आपको घंटी कैसे बजनी है ये बताना था मेरा मकसद। आई थिंक आई मेड माई पॉइंट क्लियर। Okay, great. Okay, then coming to integration by recognition. अब देखिए एक ln वाला केस हमने पढ़ लिया कि whenever there is a linear function in the denominator and we are integrating it, then it will convert to ln. Now the integration by recognition formula tells us something. It tells us, and this formula is also given in the formula sheet. This is the integration by recognition. You know what this formula tells us? This formula tells us that whenever there is a function in the denominator, whether it is a linear function or a non-linear function, when there was a linear function in the denominator, 1 upon 2x plus 3, 1 upon 4x plus 5, it used to get converted to ln. So 4x plus 5, so ln 4x plus 5 divided by 4 plus 6. But this integration by recognition tells us that if there is a function in the denominator and the differentiation of that function is given in the numerator, then the integration of that is just ln of denominator, and that's it, plus c. Indefinite, the plus c will be taken. I repeat my words. If there is a function in the denominator and the differentiation of that function is clearly seen in the numerator, then the answer of this integration will be just take ln with the denominator, and that will be your final answer. अगर डिनोमिनेटर में एक फंक्शन है और उसकी डिफरेंशिएशन न्यूमरेटर में मौजूद है, तो उस पर्टिकुलर एक्सप्रेशन की, उस पर्टिकुलर फ्रैक्शन की जो इंटीग्रेशन होगी वो सिर्फ यही होगी कि जो भी फंक्शन है उसको ln, जो भी डिनोमिनेटर में फंक्शन है उसको ln के साथ ले लिया जाए, बस दैट्स इट, वो ही फाइनल आंसर होगा और कुछ भी नहीं करना. नथिंग टू बी मल्टीप्लाइड, नथिंग टू बी डिवाइडेड, नथिंग टू बी डन. If there's a function in the denominator, the differentiation of that is seen in the numerator. We have to take ln with the denominator, and that will be our final answer. Over here, I've written k as well, just to make sure that if something that can be taken as common, so we have to take it as common as well. So just ignore k for once, for a while, just ignore k and see that if fx is there, let's suppose if there is something that is taken as common, then it will be taken as common, k will remain k in the final answer as well. But the integration, if the differentiation of fx is seen in the numerator, the differentiation of the function in the denominator, the function that is in the denominator has its differentiation present in the numerator, then we take ln with the denominator, and that will be our final answer. ln fx plus c. ln fx plus c. And if something can be taken as common, we have to take common as well, just like over here. That I will give you an example of that as well. कि अगर कुछ कॉमन निकल सकता है तो कॉमन भी लेना पड़ेगा पहले. तो दिस दैट वी स्टडीड कन्वर्टेड गेट्स कन्वर्टेड टू ln, बट कन्वर्ट होने के बाद जो ब्रैकेट की डिफरेंशिएशन होती है, दैट इज आल्सो डिवाइडेड. The differentiation of the function is also divided. But over here, if the differentiation is present in the numerator, then just take ln with the denominator, and that is it. Nothing to be divided. And the second change is that up till now that we have seen, the function was only a linear function. But over here, this integration by recognition is used for linear and non-linear, both types of functions. How is this formula derived? If you remember, we know that ln fx when differentiated becomes f prime x upon fx. So f prime x upon fx will be integrated to give us ln fx. This is the same rule that we studied in differentiation. And when ln of a function is differentiated, the function comes in the denominator and the differentiation of the function comes in the numerator. The function comes in the denominator and the differentiation of the function comes in the numerator. So ln fx when differentiated gives us f prime x upon fx. ln fx when differentiated gives us f prime x upon fx. So f prime x upon fx when integrated will give us ln fx. So this is integration by recognition. Why do we call it integration by recognition? You know why? Because there's nothing that we have to do. We only have to recognize and identify it. That's it. We only have to recognize and identify that the function that is there in the denominator, its differentiation is there in the numerator. If we are able to correctly recognize it, then giving the answer of that is just a matter of 2 to 3 seconds. That's it. So we just have to recognize and give our answer. That is why we call it integration by recognition. Nothing technical that needs to be done. The only thing that we have to do is to recognize it and we have to give the answer. So f prime x upon fx, the function in the denominator has its differentiation in the numerator. We have to recognize this case and we have to take ln with the denominator, and that will be our final answer. Now, if you look at this few examples, then we'll better understand it. 2x upon x square plus 1. The first example. We have a function in the denominator, x square plus 1, non-linear function, and the differentiation of it is there in the numerator. This is perfectly a recognition case. We have recognized it. And once we have recognized it, we know that the answer will be just taking ln with the denominator. So it's ln x square plus 1 plus. Then moving on to example number 2. 3x square plus 2x divided by x cube plus x square plus 2. So we have a function in the numerator. We have the function in the denominator. The function in the denominator has its differentiation exactly present in the numerator. Look, x cube has a differentiation of 3x square, x square has differentiation of 2x, and 2 is a constant, the differentiation of it is 0. So this means that differentiation of the denominator is present in the numerator. So we have to recognize it and we have to give the final answer like this: ln of x cube plus x square plus 2. Taking ln with the denominator, and that is it. And because it's indefinite, we are taking plus c as well. Then if we look at example number 3, we look that there's x cube plus 2 in the denominator and there's x square in the numerator. Although the differentiation is not perfectly present in the numerator. But always remember, if the differentiation is not perfectly present in the numerator, but there is a constant that we can multiply and divide, and then we can get the differentiation of denominator and the numerator, then in that case, we should multiply with the constant. And if we are multiplying, we have to divide it as well to make the net effect 0. तो मैं क्या कहने की कोशिश कर रहा हूँ, अगर डिनोमिनेटर में फंक्शन है, उसकी डिफरेंशिएशन न्यूमरेटर में मौजूद है तो सही है, लेकिन अगर डिनोमिनेटर में फंक्शन है, उसकी डिफरेंशिएशन न्यूमरेटर में मौजूद नहीं है, बट किसी एक कांस्टेंट को मल्टीप्लाई या डिवाइड करके उसकी डिफरेंशिएशन जो है वो आ सकती है, वेरिएबल मल्टीप्लाई करने की इजाजत नहीं है. वी कैन नॉट मल्टीप्लाई द वेरिएबल बाय द न्यूमरेटर टू मेक द टू टेक we cannot multiply the numerator by the variable to make it to obtain the differentiation of the denominator and the numerator. No, the variable cannot be multiplied divided. No, only the constant can be multiplied divided. अगर खाली constant का फर्क है और वो multiply divide होके आपका denominator की differentiation numerator में आ सकती है, then we'll do like that. So over here it was basically x square upon x cube plus 2. We recognized that the differentiation of x cube plus 2 is 3x square. The x square is already there in the numerator, so we just have to take plus 3. We have taken plus 3, and we have also taken 1 upon 3. So that 3 and 3 can get cancelled, but of course we are not going to cancel them. The 3 is taken over here, 3 is taken over here, and then once we can see that the differentiation of the denominator is there in the numerator, we have to take x cube plus 2 with the ln. We have to take ln with x cube plus 2, and that will be our final answer. This 1 upon 3 that is outside will come over here. And if we integrate this, then the integration of this is ln with the denominator, and that is ln x cube plus 2. So this 1 upon 3 will come over here, and 3x square upon x cube plus 2 will become ln x cube plus 2 plus. I have taken modulus. Even if you take brackets, then that is also fine, but just to align myself with that of the examiner, I have taken modulus. So are we able to understand example number 3 over here? Okay, then example number 4. X upon 2x square plus 4. As I've written over here, if there's something that you can take as common, then you need to take it as common. So what I've done over here is the first step. This is the first step. I've taken 2 as common. I've bolded this example. I've made this bold. Why? Just to let you all know that if there's something that you can take it as common, you have to take it as common first. So x upon 2x square plus 4, I've taken 2 as common. The 2 comes outside. And then we are left with x upon x square plus 2. Now the process gets repeated. Just forget this 2 for a while. This is what we have got. After taking 2 as common, we have got 1 upon 2 times integration of x upon x square plus 2. After that, what do we have to do? Now we have to recognize that the function in the denominator is x square plus 2, and the differentiation of x square plus 2 is 2x. So it's just a difference of 2. Just to obtain 2, just to take 2 in the denominator, just to obtain 2 in the numerator, we have multiplied by 2 and we have divided by 2 as well. The green part. First, this purple part, I've taken 2 as common to simplify it. Then I've obtained the differentiation of x square plus 2 in the numerator. For that, I've multiplied by 2 and divided by 2 as well. Now, the integration of this, we all know, is ln x square plus 2. And outside, we have 1 upon 4, so it will be copied as it is. So the answer is 1 upon 4 times ln x square plus 2 plus. Then if you look at example number 5, then we see that this is 1 upon 2x plus 3. So we have already seen that 1 upon 2x plus 3 is ln 2x plus 3 upon 2 plus c. But even if we are going to try this out using integration by recognition, how can we do that? And we have to check if the answer is same using both methods. Then we can directly integrate it without the concept of integration by recognition in our minds. Because 1 upon 2x plus 3 when integrated will give us ln 2x plus 3 upon 2 plus c. But if we look at this as well using integration by recognition, then what we'll do, we see that 2x plus 3 is in the denominator. The differentiation of 2x plus 3 is 2. So we have taken it in the numerator to cancel its effect out. We have divided by 2 as well. Now that we have obtained the differentiation in the numerator, it's 2 upon 2x plus 3 will be converted to ln 2x plus 3 only. And this 1 upon 2 that is outside will be copied as it is. And we get the same answer as we were doing previously. So 1 upon 2x plus 3 directly could become ln 2x plus 3 upon 2. But even if we use the concept of integration by recognition, then this works perfectly fine and we'll get the same answer. Right? So we have covered 5 examples up till now. Are we clear till here? I just need an acknowledgement. Are we clear till integration by recognition up till here? Okay, great. Alhamdulillah. We are clear till here. So we have covered first five examples. Now, if we look at 10x, if you remember, I told you that the integration of 10x and cot-x is to be done using integration by recognition. So first we'll look at it and then we'll come back to example rule 6 and 7. Now just check it out. What is 10x? The trigonometry has told us that 10x is sin x over cos x. Right? 10x is sin x over cos x. Now just look at it. There is a function in the denominator that is cos x, and the differentiation of cos x is not exactly there in the numerator, but it's partially there. And there's only one negative sign that is missing. I repeat, it was tan x. Tan x is sin x over cos x, and the differentiation of cos x is negative sin x. So we already saw sin x in the numerator. We just have to multiply by the minus sign. So I've multiplied the minus sign, and I've not just multiplied it, I have multiplied it outside as well. We can either say that I'm dividing by minus sign as well, but we know that whether we multiply by the minus sign or we divide by the minus sign, minus remains in the middle. So bottom line is I've taken minus 2 times. Minus in the numerator and then minus outside as well. So overall, minus minus gets plus. So we have not changed it overall. The effect is still a nil effect. Zero effect, right? So cos x when differentiated gives us negative sin x. So I've taken negative sign in the numerator to cancel its effect out. I've taken minus outside as well. Now the differentiation of cos x is negative sin x. So the integration of this will be ln with the denominator. So this minus will get copied as it is, and ln with the denominator will give us ln cos x plus. So bottom line is that integration of tan x is negative ln cos x plus. Also in few books, you will see ln sec x plus c. So you might get confused. How do we get ln sec x? So remember, as per the power law of logs, this minus comes at the top of cos x. So if it's cos x, minus will go at the top of cos x. It's cos x whole power minus 1. Cos x whole power minus 1 means 1 upon cos x. And 1 upon cos x means sec x. 1 upon cos x means sec x. So it will become ln sec x plus c. So this means if we say that integration of tan x is ln sec x plus c, this is also perfectly fine. But the better way is writing minus ln cos x plus c. So why do we call it better? Because let's suppose if it's a definite integral and we have to put in limits as well, then there is no function of sec x in our calculator. So if we have to substitute limits, then we have to find the values. then minus ln cos x is the best for us because that can be easily calculated using our calculators. But ln sec x cannot be calculated because the option of sec x is not there in the calculator. So even in trigonometry, we convert sec, cosec, and cot into sine, cos, and tan to solve the trigonometric equation. So this means that the version with cos is better. So it's minus ln cos x plus c. If we look at another example of tan 2x, then it's tan 2x. Just forget this. Tan 2x is sine 2x upon cos 2x. Firstly, we have rewritten it. Tan 2x is sine 2x upon cos 2x. Then the differentiation of cos 2x is sine 2x, 2 sine 2x. Cos 2x की जो differentiation है वो sine 2x नहीं है, बल्कि 2 sine 2x. So we have identified it. Then we have taken, sorry, minus 2 sine 2x, my bad. Cos 2x when differentiated gives us minus 2 sine 2x. So there was nothing over here. Cos 2x when differentiated gives us minus 2 sine 2x. So I've taken minus 2 in the numerator and also in the denominator. Then this 1 upon minus 2 is minus 1 upon 2 will be copied. And this will be integrated and give us ln cos 2x. So ln cos 2x plus minus 1 upon 2 ln cos 2x plus. Now, based on example 6 and example 8, if we look at the rule that I've written over here, tan ax plus b is minus ln cos ax plus b upon a plus c. So this means that if there's a linear function with tan, then tan gets converted to negative ln cos, and the angle, tan angle gets converted to negative ln cos angle, but the differentiation of the angle will also be divided, and because the function will always be a linear function, so it is always going to be the coefficient of x. So in this case, it's a. So minus ln cos ax plus b plus c, minus ln cos ax plus b upon a plus c. Rule number 6. We can memorize it as a rule, or we can always use recognition by recognition, because it's better that we show the detailed working, that how we have obtained the integration, because writing it as a rule, the examiner might get confused as to how the students have achieved it. But in case I've just written it as a rule as well, so that if you remember, at least the examiner will see that you have definitely done something after which you have been able to secure the correct answer. So obtaining correct answer is much better choice. So even if you remember it, then it's also fine. But always remember that integration of tan and cot is done using integration by recognition. I've left the example number 7, which is more simpler, because cot x is cos over sine, and in the denominator we have sin x, and the differentiation of sin x is cos x. Sin x की तो differentiation ही positive cos x होती है, negative का चक्कर ही नहीं है. But the differentiation of sin x is cos x, and that is exactly present in the numerator. So we have to take ln with the denominator. So it's ln sin x plus cot x is cos over sine. Cot x is cos over sine, and then it's ln sin x plus. So that is why over here it's written, if it is cot ax plus b, then integration of this is ln sin ax plus b divided by the differentiation of the angle plus. So ln sin ax plus b upon a plus. So tan ax plus b is negative ln cos ax plus b upon a plus c, and cot ax plus b is ln sin ax plus b upon a plus c. How have they been obtained? They have been obtained using integration by recognition. Right? So all 8 examples have been thoroughly explained, and the 6th and 7th rule that I left previously have also been explained, that they have been derived using integration by recognition. Just give an acknowledgement as to whether you people have been able to understand till here or not. यहाँ तक बात समझ आई है? कोई बात अगर आप चाहते हैं repeat करना तो मुझे बता दें, I will repeat it, because we are going to keep it till here only. क्योंकि आगे फिर थोड़ी complication शुरू हो रही है, वो उसको इंशाल्लाह easy है, मतलब मुश्किल नहीं है, लेकिन थोड़े और parts हैं, उसको समझाने में time लग जाएगा. And as I have told that today we are going to keep till here only, inshallah. We are going to complete this category in the next class, hopefully, inshallah. After that, after which you'll be able to attempt the past papers as well. So by that time, you have good time till then. You have few days to complete the wind-up differentiation. So wind up all the categories of differentiation by that time, inshallah. I will complete the integration category, integration explanation in the next class. And then after which you'll be able to do the past papers as well. ओके मैं पार्ट 8 समझा देता हूँ. आलिया माइक पे आ जाए, थोड़ा सा बता देता हूँ, सुने. माइक ऑन करें.
जी सर.
देखो tan 2x क्या होता है? sin 2x अपॉन cos 2x होता है।
जी।
अच्छा, उसके बाद मुझे बताएं cos 2x की डिफरेंशिएशन ऊपर चाहिए, तो cos 2x की डिफरेंशिएशन क्या होती है?
सो माइनस वाला होता है।
cos एंगल की होती है नेगेटिव साइन एंगल मल्टीप्लाई बाय डिफरेंशिएशन ऑफ एंगल, है ना। तो cos 2x की हो जाती है -2 sin 2x होती है।
जी।
तो मैंने -2 लगा दिया ताकि डिफरेंशिएशन डिनोमिनेटर के ऊपर आ जाए। अब जब -2 मैंने ऊपर लगाया तो उसका इफेक्ट कैंसिल करने के लिए मुझे -2 डिनोमिनेटर पे भी लगाना पड़ेगा बाहर, ताकि नेट इफेक्ट 0। cos
तो वो
2x की
माइनस
डिफरेंस,
माइनस कैंसिल क्यों नहीं होता है उसके बाद?
तुम कह रही हो माइनस माइनस कैंसिल कर दूं?
जी।
देखो ये तो था ही नहीं ना, ये तो मैं खुद ले रहा हूँ। जब एक चीज मैं खुद से लगा रहा हूँ तो उसको कैंसिल क्यों करूंगा फिर? उसको तो ले ही इसलिए रहा हूँ ताकि मेरे ऑब्जेक्टिव्स मीट हो। फॉर्म तो चेंज होगी लेकिन ओवरऑल मैं इसलिए 2 दफा लेता हूँ ताकि ओवरऑल चेंज मैं सेटिस्फाइड हूँ कि मैंने ओवरऑल चेंज कुछ नहीं किया, खाली शक्ल बदली है। ओवरऑल तो वही है, लेकिन शक्ल इसलिए बदल रहा हूँ बिकॉज आई नीड द डिफरेंशिएशन ऑफ cos 2x इन द न्यूमरेटर। उसके लिए जब मैंने -2 मल्टीप्लाई किया न्यूमरेटर में, तो उस -2 के इफेक्ट को कैंसिल करने के लिए डिनोमिनेटर में -2 लिया। अब आप ये वाली जो चीज होती है इसको एज इट इज कॉपी कर देते हैं, और जब मुझे यहाँ तसल्ली आ गई कि cos 2x की डिफरेंशिएशन ऊपर मौजूद है -2 sin 2x, तो मैं डिनोमिनेटर के साथ ln ले लूंगा। आई विल टेक ln विद द डिनोमिनेटर।
ओके सर।
जवेरिया सही है, आले समझ में आ गया?
हाँ जी सर, क्लियर हो गया।
जी जवेरिया, कैंसिल को कैंसिल क्यों करते हैं, इफेक्ट को कैंसिल आउट क्यों करते हैं? कभी ओ लेवल में आईजीसीएसई में सवाल देखा 0.2/5 को एज अ फ्रैक्शन इन सिंपलेस्ट फॉर्म करें? So we used to multiply by the numerator and then we also have to multiply with the denominator 10. It becomes 2/50, which simplifies to 1/25. तो क्यों ऐसा करते हैं? डेसिमल हटाने के लिए खाली न्यूमरेटर को 10 से मल्टीप्लाई कर देते। Why we multiplying 10 with the denominator as well? क्योंकि मैथ्स में कभी भी कोई काम करते हैं वो एक दफा नहीं करते, ओवरऑल चेंज कभी भी नहीं करते हम। कोई भी काम करते हैं 2 दफा करते हैं ताकि नेट इफेक्ट 0। ये जरूरी है। मिसाल है x² - 5x = 10, -x² + 5x = 10। अब मुझे -x² को +x² बनाना है, तो मैं माइनस से मल्टीप्लाई करता हूँ। तो माइनस से मल्टीप्लाई सिर्फ x² को करके +x² कर दूं ना, बस काफी है? नहीं, मैथ्स कहते हैं ऐसा नहीं हो सकता, सबके साथ करना पड़ेगा। -x² बन गया +x² +5 बनेगा -5x और इक्वल टू के बाद +10 बनेगा -10। जो चेंज होगा सबके साथ होगा, ओवरऑल चेंज होगा, पूरे इक्वेशन में चेंज होगा। तो कोई भी ओवरऑल चेंज हम मैथ्स में नहीं कर सकते, जो काम करते हैं सबके साथ करते हैं ताकि ओवरऑल नेट इफेक्ट 0 हो। ये हमारा उसूल है, ये मैथ्स का बेसिक उसूल। लिहाजा मैं अगर -2 से सिर्फ मल्टीप्लाई कर दूंगा तो ये गलत कर दिया मैंने अपनी तरफ से। कुछ भी जिसका जो दिल जाएगा वो मल्टीप्लाई डिवाइड करेगा, ऐसे तो कोई ड्रामेबाजी थोड़ी चल रही। जब मैंने न्यूमरेटर में मल्टीप्लिकेशन की है तो डिवाइड भी करूंगा ताकि नेट इफेक्ट 0 हो जाए। सही है, तो ये आपके 8 एग्जांपल्स मुकम्मल हो गए। इंटीग्रेशन में रिकॉग्निशन वी हैव स्टडीड, अंडरस्टूड, and a few basic principles of integration along with integration and recognition have been covered. Inshallah, more things will be covered in the next class. Okay, so I think everyone is clear till here. See you in the next class. Remember me in your prayers. अपना बहुत सारा ख्याल रखिएगा, दुआ में मुझे याद रखिएगा। अपना बहुत सारा ख्याल रखिए। अस्सलाम वालेकुम व रहमतुल्लाहि व बरकातुहू।